Hello everyone to the last video on this series on algebraic methods. My name is Ali-Ayman and I am an electrical and electronics engineering student at the University of Edinburgh. On this channel we'll be looking at study related content and self-development. If that interests you, if you wish to properly ascend in terms of the knowledge you have and the heights you aspire to reach, whether it be in exams, whether it be in self-development, etc., etc. Stick around on this channel. Trust me, this is the best place for you. Today we'll be looking at, as I said, the final topic on this series. We'll be looking at rationalizing the denominator. So, if a fraction has a surd in its denominator, for example, in this case 1 that I've illustrated here, the surd would be root a, which is in the denominator of the fraction. Same thing in case 2. We've got root b here, and we've got root b here in case 3. So if a fraction has a surd in its denominator, then it's useful and practical to rearrange it so that the surd is no longer in the denominator. And that process is called rationalizing the denominator. The process of rationalizing the denominator can be done in 3 ways, depending obviously on the question. What I mean by that is the fraction you have, basically. What kind of is the surd? Is it just a surd that's in the denominator? Is it a surd plus another integer, or is it an integer minus a surd? These are all things we have to keep in mind when rationalizing different fractions with surds in their denominator. And the 3 cases are illustrated here: case 1, case 2, and 3. We'll look at them each one by one. So let's start with case 1, and let's see how we would go about rationalizing the denominator of this particular fraction. Well, what we would have to do in this case is multiply the numerator and the denominator by root a. So what that does is, when we multiply fractions, we multiply obviously the numerators and the denominators. 1 times root a is root a, and root a times root a is just a. And just like that, we've rationalized the denominator of this fraction 1 over root a. So that's it for case 1. Now for case 2, we've got 1 over a plus root b. In this case, we have to multiply the numerator and the denominator by a minus root b. And the idea here is when we multiply a plus root b and a minus root b, the a root b's will cancel out, and I'll show you what I mean in a second. So let's first start off by simplifying this. 1 times a minus root b is equal to a minus root b. And that's all divided by a plus root b times a minus root b. And obviously, to expand this, we use the exact same principles we looked at in the second video on this series, and that's expanding the brackets. So basically what we do is we multiply each term in one bracket by all the other terms in the other bracket. So we would have to do a times a times negative root b times a, and root b times negative root b. I suggest you check out that video if that seems unfamiliar. So when we expand the denominator, we obtain a minus root b all divided by a squared, because a times a is a squared, minus a root b plus a root b plus b, because b times, minus b, because root b times negative root b is just negative b. And now what I was talking about when I said the point is to cancel out the a root b, as you can see here, this denominator simplifies further. The negative a root b and the plus a root b cancel out, leaving us with just a squared minus b. And we've achieved the objective of removing the surd from the denominator, and as a result, this fraction has therefore been rationalized because this root b is no longer in the denominator. Now for case 3, we've got 1 over a minus root b, and in this case, in order to rationalize this fraction, we multiply the numerator and the denominator by a plus root b. And you can now see the pattern here. In case 2, the denominator had a plus root b, and in this case we multiplied both the numerator and the denominator by a minus root b. In other words, the converse or the opposite of a plus root b is a minus root b. However, in case 3, in the denominator we have a minus root b. So in order to simplify this fraction, we have to multiply the numerator and the denominator by the converse of a minus root b, which is a plus root b. So in order to simplify this, 1 times a plus root b is equal to a plus root b. And as before, we end up with 2 brackets multiplying together, a minus root b multiplied by a plus root b. And that simplifies to a plus root b, and then when we expand the brackets in the denominator, we obtain a squared plus a root b minus a root b minus b. And this time we obtain the final answer of a plus root b, all divided by a squared minus b. And again, a and b, in all 3 of these cases, usually they'll be integers, but they can be any real number which is not negative, because remember, we cannot square root a negative number unless obviously we're dealing with complex numbers, but that's a whole other topic for another time. So again, we mentioned that when we're rationalizing the denominator, the whole point is basically trying to rearrange or get rid of the surd in the denominator of a fraction and bringing it, if you'd like, to the numerator instead. That's basically what we're trying to do here. Now let's look at this set of examples. We have been told we have to rationalize the denominator of all of these fractions. So for part A, we've got 1 over root 3. And the way we rationalize the denominator of this fraction is to multiply the numerator and the denominator by root 3. This obviously resembles the case 1 we looked at earlier, so we just multiply the numerator and the denominator by the surd of the denominator, which in this case is root 3, and 1 times root 3 is root 3, and root 3 times root 3 is just 3. And that's the final answer for part A. And now for part B, we've got 1 over 3 plus root 2. This resembles the second case we looked at above, and in this case we've got 3 plus root 2 as the denominator, and the way to simplify this fraction would be to multiply the numerator and the denominator by the converse of 3 plus root 2, which is 3 minus root 2. 1 times 3 minus root 2, sorry, is 3 minus root 2. And then in the denominator, we've got 3 plus root 2 times 3 minus root 2. And now we have to expand the brackets. So as before, all the terms in one bracket must be multiplied by all the terms in the other bracket. So we end up with 3 minus root 2, all divided by, obviously 3 times 3 is 9. 3 times negative root 2 is negative 3 root 2, and then 3 times root 2 is plus 3 root 2, and then root 2 times negative root 2 is just negative 2, and then this simplifies further. So we end up with 3 minus root 2 all divided by, obviously 9 minus 2 is 7, and then obviously this just cancels out. Minus 3 root 2 and plus 3 root 2, they cancel out, and this is just the final answer, 3 minus root 2 over 7. We've cancelled out the surd, and as a result the initial or the starting fraction has been rationalized, and that's the final answer. Now for part C, we have root 5 plus root 2 all divided by root 5 minus root 2. So this time in the denominator we have root 5 minus root 2, and we've got a negative sign before the root 2. So we have to multiply both the numerator and the denominator by the converse of root 5 minus root 2, which happens to be root 5 plus root 2. And then after doing this, we end up with a pair of brackets that have to be expanded on both the numerator and the denominator. So we end up with root 5 plus root 2 times root 5 plus root 2 all divided by root 5 minus root 2 times root 5 plus root 2. And essentially what we have to do now is expand the brackets, expand both sets of brackets, the ones on the numerator and the ones on the denominator. So root 5 times root 5 is just 5. Root 5 times root 2 is root 10. And then once more, root 2 times root 5 is also root 10. And then root 2 times root 2 is just 2. And this is all divided by root 5 times root 5, which is 5. Root 5 times root 2, which is root 10. And then negative root 2 times root 5, which is negative root 10. Then root 2 times negative root 2 is just minus 2. And then simplifying the numerator, we end up with 7 plus 2 root 10 all divided by 3, because the root 10s cancel out and 5 minus 2 is 3, and we end up, and obviously after simplifying the numerator, this is the final answer we end up with, and we have removed the surds from the denominator, and as a result this fraction here has been rationalized, and this here is the final answer. So now for part D, we've got 1 over 1 minus root 3 squared. So the way to tackle fractions like this would be to first of all rewrite this denominator as 1 over 1 minus root 3 times 1 minus root 3. Because if a pair of brackets is raised to the power 2, that's the same as writing two sets of the same brackets and then multiplying them together, which in this case is 1 minus root 3 times 1 minus root 3, because we have 1 minus root 3 all squared starting off. And then we have to expand the denominator now. So 1 times 1, 1 times 1 is 1. 1 times negative root 3 is negative root 3. Negative root 3 times 1 is also negative root 3, and then negative root 3 times negative root 3 is just plus 3. The answer we end up with is 1 over 4 minus 2 root 3, because 1 plus 3 is 4, and then negative root 3 minus negative root 3 is negative 2 root 3. But we're not done here. The surd is still present in the denominator, so we have to multiply the numerator and the denominator of this fraction by the conjugate of 4 minus 2 root 3, which is 4 plus 2 root 3. Okay, so 1 times 4 plus 2 root 3 is just 4 plus 2 root 3. And then the denominator will be 4 minus 2 root 3 times 4 plus 2 root 3. And we have to expand the brackets, obviously, in the denominator. And this all equals 4 plus 2 root 3, the numerator, and then 4 times 4 is 16. 4 times 2 root 3 is 8 root 3. And 4 times negative 2 root 3 is negative 8 root 3. And then negative 2 root 3 times 2 root 3 is equal to negative 12. And this all, when we simplify, the denominator, we end up with 4 plus 2 root 3, all divided by 16 minus 12 is 4, and 8 root 3 minus 8 root 3 is 0, so we end up with this as the final answer, and we can rewrite this fraction as, if we split it up, because all the terms in the numerator are all divided by all the terms in the denominator, so if we divide 4 by 4 we get 1, then 2 root 3 divided by 4 is just root 3 over 2. That is the final answer. We expanded the brackets here in the denominator, we simplified the resulting answer from the expansion, and then we rationalized the denominator by multiplying the numerator and the denominator by the conjugate of 4 minus 2 root 3, and we simplified, all the resulting answers we got, and this was the final answer as a result. So here's the exam style question I have here for you to try. Please use what you've learned in this video and in the previous videos, mainly obviously the expanding the brackets concepts we talked about in the second video, and attempt this question here. So, pause the video, attempt this question, and then once you're done, resume the video and compare your answer with mine. All right, so as always, I'll be, completing this question as though I'm in an exam style situation. So I'll start off by rationalizing the denominator immediately. So the converse of root 5 minus 1 is negative root 5 minus 1. And then we end up with a pair of brackets on both the numerator and the denominator. And we have to expand both brackets on the numerator and the denominator. 3 times negative root 5 is negative 3 root 5. 3 times negative 1 is negative 3. Negative 2 root 5 times negative root 5 is just plus 10. And negative 2 root 5 times negative 1 is plus 2 root 5. Then this is all divided by minus 5 minus root 5 plus root 5 plus 1. The numerator simplifies to 7 minus root 5, all divided by minus 4. And now it wants us to give our answer in the form p plus q root 5, where p and q are rational numbers. So in other words, here we have to divide all the terms in the numerator by the denominator. Let me just fix this. So we have to do 7 divided by minus 4, which is minus 7 quarters, and then plus root 5 over 4. And that's the final answer. So the final answer is negative 7 over 4 plus root 5 over 4. Okay, so this is the end of the video. We have now completed the series on algebraic methods. This was the very first topic we covered in our much longer series on, hopefully longer series on pure mathematics. And as you can imagine, in the grand scale of things, this topic was quite trivial, compared to the topics in pure mathematics, or like differentiation, integration, complex numbers, the topics from chemistry. you could stay tuned for all these upcoming topics. If you like this video and you want to see more videos like this and on other topics, feel free to subscribe, share and like the video. And just to recap, today we looked at rationalizing the denominator. We have seen that it's basically a means by which we can remove the denominator or rearrange the denominator, the surd which is in the denominator. We can rearrange or remove it by multiplying the numerator and the denominator by a surd, and depending on the cases we've outlined, what exactly we're going to multiply the numerator and the denominator by depends on the case we have, and we've illustrated what we do depending on each case. So I hope you've learned the concepts that I try to demonstrate in this video. And make sure you look at the practice questions I put in this video and in all the previous ones. And yeah, I will see you in the next series. I'll be starting soon. Stay tuned to know what it is, and I'll see you there. Goodbye.